Alright guys, so now we're going into Chapter 9, and Chapter 9 is really an extension of 1.7. 1.7 we learned about our different translations, whether it be transformations, whether it be a translation, which is just a shifting of a figure. You get your reflections, where you reflect over a line, and you got your rotations, where you rotate about a point. So this is, again, just an extension into that. 9.1 is going to be specifically on reflections. So we got a little warm-up here, some things that we may need to be aware of about congruency. Now you got to understand at this point that we have skipped a few chapters, just a few. We went from Chapter 1 to Chapter 9. So I will kind of fill you in on a couple of these things, but if you think you can do the warm-up on your own, give it a shot first, and then we'll kind of fill in the blanks from there. If not, then don't pause it and go ahead and follow along. Okay, so first off on this one, the first thing I want to kind of literally highlight here, is a statement and what it means. And we're going to go over triangles, obviously, sometime between Chapter 1 and Chapter 9. And anyway, if you're talking about this statement, you need to understand a couple things about what it means, and some of it we've already actually talked about. And that part here is this guy right here, which means congruent. So you need to understand what congruent means and how it's different from equals. And when you have your congruent, and I'll put a couple little side notes up here to give you a reminder. Congruent is that symbol that we just talked about. Okay, and when you have something that's congruent, that means that you're talking about the figure. So I'll say the figures are going to have the same size and shape. Okay, so congruent is talking about a figure, and when you're talking about equals, I don't think I need to say what that means, but I'll say it anyway. So equals, these are going to talk about numbers. So a couple ways you can do it. They're going to have the same, you can say they're things that have the same length or measure, or angle measure, I guess you can say. I'll just say measure in general, because that way it can go a few different ways. The key on this is that you're talking about numbers. So we want to make sure we know what those mean. That's a common mistake or error, or thing that students kind of get backwards or don't think much about. We're talking about equals, congruent. They kind of say or talk about them in the same way, but they're not the same thing. They mean different things. Congruent is talking about a shape, and equals is talking about the measurements of that shape. So anyway, long story short, here we go. The warm-up says, given that triangle ABC is congruent to triangle DEF. So here's kind of what that means. So we'll write it over here off the side. So I'm going to triangle ABC, and I'll just draw a regular, let's do a right triangle just because. They didn't say what kind of triangle it was, which means we can draw any triangle that we want. So the thing is, when you draw this, I'm going to call this angle A, my right angle. So this will be angle B, and this will be angle C. So to keep track of our angles, I'm going to use one arc to measure angle B. So it has a measure, but I'm going to use two arcs to measure angle C. What I'm trying to say here is that angle B and angle C are not congruent angles, which means that they don't have equal measures. So again, those mean two separate things, but they kind of, I can talk about them together. So anyway, that's my triangle ABC. Now when you say that it's congruent, so I want to say it's congruent to triangle DEF, go ahead and draw that. So triangle DEF, and I'm going to draw it going the same way and all that good stuff. So there's triangle DEF. I'll make a little right angle there. There's D, there's E, and there's F. Now the key on this is the following. You need to make sure that A is in the same spot as D, You need to make sure that B is in the same spot as E, and you need to make sure that C, I'll cross over here, is in the same spot as F. They have to be written in the exact same order. So in this case, that's what I did. If you can kind of watch the way this is written, they are written in the same order. A is with my right angle, and so is D. B was second, it's on top. E was second, it's on top. So it's going to have your one arc. And then F is obviously the last one. It's on the bottom right. It's going to have the 2 arcs. So these are congruent. Okay, so I can have that written out for you now. We have our congruent angles, or triangles. Okay, so we want to identify a segment or angle congruent to each of the following. So angle B, notice it's the second letter. If you have the picture to go along with it, it's easy to tell that angle E, that's supposed to be an angle, it looks like an L, so I'm going to fix that. But this answer would probably be angle E, not probably, it is angle E. So angle B is congruent to angle E. AC. AC is the bottom segment. Again, I put these in the exact same order so you can see that what matches it. But look, AC, first letter, last letter. DF, first letter, last letter. See how it's the bottom and that's the bottom? So they should match here, and they'll match on your figure if you wrote it correctly. So AC is congruent to DF. Okay, angle A. Angle A is your right angle, so that's congruent to angle D. I know I'm going out of order just a little bit here. Okay, number 2, we got DE. So DE, I'm looking over here, it's that vertical side, or the first 2 letters in your statement. Vertical side, first 2 letters in your statement is AB, so it's congruent to AB. Notice I'm putting that segment on top. So again, remember, congruent's talking about the shape. So this is the shape. Next up, we have angle F. Angle F is my second triangle. It's the last letter for the last vertices, so that matches with C, but your picture matches that as well. F has the 2 arcs, C has the 2 arcs. So angle F is congruent to angle C. And finally, BC. BC is the hypotenuse of that first triangle, so EF would match it. So it's congruent to segment EF. Now, by the way, if I said some of these other statements, you don't need to write this part down, but if I was talking about the length of DE, it would be written like this. The length of DE equals the length of AB. The measure of angle F equals the measure of angle C, and the length of BC equals the length of EF. So again, if I was writing it in terms of length, I would use equal signs. Again, they're not asking for that here, so you don't need to write that. If you have it, great. If you don't, oh well, you'll be fine. Alright, so that's going to be the warm-up for 9.1. Alright, so now we're going to move into the lesson on 9.1. And again, 9.1, we're going to focus on reflections. Now, we've done reflections briefly. We didn't go over it too much because it was a warm-up in 1.7. But we're going to obviously go into it in a little bit more detail today. So 9.1, again, is on reflections. So your goal for today is to be able to identify and then also be able to actually draw reflections. So that's our only real goal for today. So hopefully it won't be so bad. So here we go. Let's move down here. Okay, so obviously we're going to have some definitions that you need to know. So one here is an isometry. So you may want to write this down or highlight it in your glossary. So anyway, we have an isometry is a transformation that does not change the shape or size of a figure, which sounds pretty familiar to the definition I gave you for congruency. So you'll see a little bit of connection there. Reflections, translations, and rotation are all isometries, and we have an idea of what all 3 of those are because we've done them before. So isometries are also called congruence transformations. Again, I want you to remember that word congruence. We already kind of brought that up a minute ago. Or rigid motions, because they're not really changing the size or the shape of the figure. Now you can rotate it or flip it or slide it, but you're not changing its actual size or shape. So again, I'm just reading through here so we can follow along as I go. Recall the reflection is a transformation that moves a figure, the preimage that we learned from 1.7, by flipping it across a line. And typically that line, to make it easy, could be the x-axis or the y-axis. That's what we saw in some of our homework. But in theory, it could be any line. It doesn't have to be one of those axes. So the reflected figure is called the image, and that's the final figure. And a reflection is an isometry, because it doesn't change the size or shape of your figure when you flip it. So the image is always congruent to the preimage. Okay, again, that word congruent coming up. So congruent and isometry kind of go together. They don't mean the same thing because it has to do, an isometry has to do with a transformation. But again, a transformation, its preimage and its image are always going to be congruent. Alright, so we want to be able, again, one of our goals is to identify a reflection. Now, again, remember, reflection is where you flip something over a line. So if we're looking at these two, and again, you want to write down these examples. So obviously, if you need to pause it so you can get these figures drawn real quick, and then we'll talk about the actual reflection or lack thereof. Okay, so for A, what we're trying to do is see is it being flipped over a line. So you start by just drawing a line that if it was being flipped, it'd be flipped over that line. That's an ugly line, but I can fix that. Yes, I can try to fix it. Probably won't be good. I can never draw these lines. Yeah, that'll work. Okay, so in this case, what we're trying to do is see is this being reflected. And if it was being reflected, you should notice that if I go this distance on the left side of the line, and I go the same distance on this side of the line, I should have this point. In other words, this guy should be sticking out, and it's not. So this would be no, because it's not going to be a reflection. This would be a translation. They're not really asking you for that, but we're going to write it because we did 1.7 already. So we know what a translation is. Okay, I just slid it over. Now this one, if you draw your line, again, mine won't be very good, but you can get the idea. Mine's always ugly, but whatever. Okay, I'll try it one more time because I want it to try to line up if I can. Okay, so the goal here is to get this to line up as much in the middle as possible. That's better. And this way, when you draw a line or a line segment, you should go from this point, and if you flipped it, that little distance right there should match that distance on the other side to get to the same exact point. You can kind of see the flip over here, but again, I want to make a highlight of that concept right there. That distance is going to be the same if those are going to be reflections. So this would be a reflection. You just say yep, or yes, or yeah, or whatever. Smiley face. Yay, we got it. All right. Okay, so that's going to be your reflections. And again, you just want to be able to make sure you can see a reflection, and you know, if you did 1.7 and understood 1.7, you can probably do that already. Okay, moving on. All right, so same thing. This is really the same basic premise. So this is something you can kind of try on your own here before we kind of go over it if you needed help on that last one. But again, we just want to be able to tell whether each transformation appears to be a reflection. We're not proving that it is, but if it looks like a reflection, you know, we can kind of go with that. Okay, so on this one, what you have is, you know, if you drew that line right down the middle, these parts should be matching. Now you got to be careful here and kind of see, like, it looks like I got the really pointy end on this blue one right here. So if I reflected it over this line, it looks like we're good because those lengths are the same, but that's not the same point. If you look at this really long pointy end, it should be over here. So these actually aren't lining up if I tried to flip it over that line. So this is going to be no. You would say this is a rotation. Oops. This a rotation is not proper English, so I'll change that. This is a rotation. Okay, but if you come over here, look at B. This line is not a vertical line. It's going at an angle, but it's still a line nonetheless. So if I can get this line to look somewhat straight, you should be able to match a couple of points here and reflect it. So I'll kind of use this point. Again, this point looks the same as this point. And if I drew this segment and that segment, those lengths are going to be the same. And if I did that with every single point on that figure, it would all line up. You can kind of see that. So this would be another yep. Smiley face, whatever you want to do. All right, it's a reflection. Okay. Again, knowing the homework here, we're going to have some time to work on it in class, but as we're going over these, remember these questions on page 607, they align with this example, so you should be able to go right ahead and knock those out. It'll be less work for you in class. Now the rest of it we'll save for class because that's what we have time to, that's what we have our time for. But you can knock some of it out already. Okay. All right. So one thing I've been talking about with reflections and how you recognize them is this congruence, the congruent segment concept. So reflections is a transformation across a line called a line of reflection. So that's the line I was drawing. I was trying to draw it straight. I wasn't doing a good job. But again, we have that line. So that line of reflection is the perpendicular bisector. We're going to need to talk about that word. This is what happens when you skip chapters. Don't blame us. It's the county. They make us do that. We have to skip. Okay. But we have the line of reflection is the perpendicular bisector of each segment joining each point and its image. And perpendicular bisector, you have to understand what each word means so that you can break it down. Now, we've already talked about the word bisector, but perpendicular means that you're going to have a right angle. So that means that you're going to have one of those guys. And bisector, that means cut in half. So as you look over here at this figure, what perpendicular bisector means is that we got these 2 points. See how think of this A to A prime as a segment, and that segment is being cut in half. So we have these 2 congruent pieces, but it's being cut in half by a perpendicular line. That's how we're kind of putting these 2 things together. So perpendicular means that, bisector means this. They're just putting both of those words together. So think of the point of intersection here as the midpoint, because that's what it is. Okay, that point is the midpoint. This line is perpendicular. So again, you got to know each word. If you know each word, you can probably make out what perpendicular bisector means. Okay, but that's obviously an important part of our reflections is being able to recognize the line of reflection and the fact that line of reflection is going to be a perpendicular bisector from any point to its prime point. Okay. All right, so example 2, we're going to copy the quadrilateral and the line of reflection. So we have the figure here, and draw the reflection of the quadrilateral across the line. So when you do this, it's nice if you have a straight edge and you can do everything perfect. I don't have that benefit here, but I'm going to try to show you as best I can how to do this figure. So first thing I'm going to want to do is label my vertices, and we're going to do that first. And again, I would recommend drawing this first. So if you need to pause this, I'd pause it before you get too far here. Okay. All right, so I'm going to have my points. I'm just going to call this A, B, C, and I'll call that point D. Now, in order to draw its reflection, we need to be able to do perpendicular bisectors. Now, it's just want you to copy the line of reflection, draw a reflection across the line. We're going to do the best job that we can, but what I'm concerned with on this, if I'm checking your work, is how you draw it. And we got to draw it by showing that this line right here is going to be your line of reflection. What that means is that it's going to serve as the perpendicular bisector from the segment containing A to A prime, B to B prime, C to C prime, and D to D prime. If you don't know what that all means, that's what I'm here to show you right now. So here we go. We have our first line. I'm going to draw a segment from A down to A prime as I'm doing that, it's going to form a right angle with our line of reflection. Now again, all I can really do in this is estimate it. So I'm going to keep going, trying to draw it around the same distance. And I'm going to call that point A prime. And I'm going to do that with every single point. And again, just to make sure we understand what's going on, those segments are congruent. The distance from the line of reflection to A is the same distance as it is from the line of reflection to A prime. So again, we're going to do that with every single point. So I'm going to come over here to B now, do the same thing. Again, that's forming a right angle. I'm going to try to go the same distance. Again, I'm doing my best. I think I go that a little farther than that. That doesn't look congruent. So I'll go a little farther. That looks a little bit better. I'll call that B prime. And again, the key is just make sure you label those two segments congruent as well. Now notice what I'm doing here, because they're not, these four segments that I've drawn so far aren't all congruent to each other. So I want to use 2 tick marks on these, and that tells me that yes, these 2 segments are congruent, but they're not congruent to those other 2 that I drew. So next up I have D, and I'm going to go D to D prime. So I got this little segment and that little segment. So that'll be D prime, and I'll go 1, 2, 3. It's going to be really tiny there. 1, 2, 3. So I got 3 tick marks to kind of show that those aren't congruent to anything else as well. And finally I got C to C prime. So draw your perpendicular segment down here to your line of reflection and do the same thing on this side. And I'll go C prime and 4 tick marks. 1, 2, 3, 4. 1, 2, 3, 4. Alright, so now I'm going to go ahead and attempt to draw this image from the pre-image here. So I'm going to do my best to connect these points and try not to butcher it too much. So starting here at A, I'm going to draw a segment all the way over to D. And then I'm going to go over here to C. And then we can connect it to B. And from A to B. Again, mine is not going to be the prettiest because I don't have a straight edge, the luxury of that. Yours should look a lot better than mine. If you have a ruler, that'd be even better. We haven't really gone over the construction part yet, so that would kind of make it another way that you could approach it. But again, if you can get a image that looks like your pre-image but a reflection, you're good. But the thing I have to see, the only way we know that you understand what we're doing, is we gotta see these segments right here. You gotta show me that you understand how to get those points, so you're not just guesstimating everything. Okay, if you can do that, you're going to be in great shape. Alright, moving on. Example number 3. Now, so again, just so you know, we just covered example 2, so you should be able to do 17, 18 now. So if you want to approach those problems, you can now approach those and should be able to tackle them pretty well. Alright, so let's look at example 3 now. A little bit of application problem solving. I need to understand what they're saying here before you just jump and answer it. So here we have 2 buildings are located at A and B, and they're going to be connected to the same point on the water line. So what we're trying to do in a situation like this is we're trying to find a point on this water line. So where should they connect so that the least amount of pipe is used? So I'm trying to find a point to go to both of those. Okay, so this could be a little tricky. I'll kind of walk you through a quick way to do this. And for one, you know, the shortest distance between 2 points, you want to make sure you realize is a straight line. So this would be the shortest distance between points A and B. Now unfortunately, our water line is not located on that. But there is a unique way to attack a problem such as this. And that way is to do a reflection of point B. And I'll show you what I mean when we draw it. But we're going to do a reflection. Now remember how we do the reflection. We draw our line to the line of reflection, which in this case is the water line. And then we draw that same, draw that segment on the other side at the same distance. And we're going to have B prime. Now that is not where your building is located, but check this out. now what you can do is you can now connect these two lines. If I can, that does a terrible job because that's kind of curved. Again, you have no idea how hard this is to draw on here. That's a little bit better, so we'll make that work. So I know this is the shortest distance between B and B prime. So what's going to happen is it's going to intersect that water line. Okay, and again, what you're kind of doing here is you're setting up two congruent triangles. The two congruent triangles are these right here. Remember we talked about congruent triangles earlier? Well, these are the congruent triangles. So this is, if you kind of notice, the shortest distance between A and B prime is this line right here. Well, it's the same as if I took this shortest distance and I reflected it, that whole line, over the water line. So what that would mean is if I had my water line coming from this point P going to B and to A, that would represent the shortest or the least amount of pipe used for both of those, to get to both of those buildings. So in this case, point P, this is how you kind of show it, reflect, draw your line, and you're going to have your two congruent triangles that kind of prove that this would be the shortest distance to both of those. So in this case, that'd be point P. Okay. That one can be a little tricky. Kind of understand that process of what I did there to try to help you out. There is another piece on this slide. Kind of tries to explain what's happening here. Maybe the drawing's a little bit better. That's kind of telling you how to approach this example. And again, reflect B across the water line to locate B prime. So that's your starting point. And then we're going to draw AB prime. That's what I did, right? And locate X, I called it P, at the intersection of AB prime and the water line. So again, what happens is, like I said, this point X is where you want to put that pipe because it's going to create the shortest distance between both of these points. Okay, because again, this would represent the shortest distance from A to B prime, and then you're reflecting that line over here and using that as our two pipes. Okay. All right. Next up, if A and B, this is extension here, if A and B were the same distance from the river, what would be true about AX and BX? So again, I'm going to look back on this previous slide since I have a nice picture to go along with it. Hopefully you have it drawn and you can use yours. It's better than mine. But again, if A and B were the same distance from the river, what would be true about AX and BX? So we have AX and we have BX. So if it's the same distance, now right now what they have drawn is that BX and AX aren't the same length, but if you look back here, what they're saying is if A and B were the same distance from the river, what would be true about those segments? Well, they're not right now. If they're the same distance, you'd have to have something like this. A would actually need to be out here, or you can move B in here. You know, regardless, it would have to be a different figure. So if they were the same distance, then that would mean that these segments would be congruent. So you'd be able to say something like AX would be congruent to BX. Again, they're not, but if they were, that's what you'd be able to make a statement from. I mean, that's really all they're asking in that case, if they were congruent, which they're not. Okay, so you basically in this point be able to say AX is congruent to BX. It's the same as I wrote in the other one. All right. So again, that one kind of coincides with number 19. Obviously, as you go through some of the other examples, you'll be able to see more with that that goes with that example. But you should be able to go ahead and try number 19 at this point. Again, any questions you have on any of these problems, you can still kind of bring those questions with you when you come into class. All right, next up, we're going to have the algebraic properties that go along with reflections. I'm going to just tell you right now, you need to know these. It's going to be extremely important that you understand what these are and how to use them. If I was going to put stuff on a quiz, this would be one of the first things that I'd be looking at. So make sure you know all three of them. That's a big hint. Usually, if I give you a hint, please take advantage of it. If I say something's going to be on a quiz, guess what? You're probably going to see it on a quiz. Okay, so know all three of these. If you know them, you're going to be, that much better off for it. Now, a couple of these, the two of them are kind of common sense. If you look, you have your reflections across the x-axis and the y-axis. Those, again, for the most part, are pretty straightforward if you understand them, but again, people are going to try to get them backwards if you try to just memorize it, and I really don't want you to memorize these. I want you to understand them. Huge difference, because if you understand the concept of reflecting a point over the x-axis, it would make sense that the y's flip, because your x value is not changing. You're going vertically in your reflection, so the y's would change. Same thing if you go across the y-axis. Your y's don't change. You're moving horizontally in that case. So again, understand that the x values change. Again, we had a question that asked you to discover that on your own in 1.7, so hopefully you've seen it already and it makes sense. The other one, this is actually a pretty important algebraic concept, reflecting across the line y equals x. Not that you need to know this right now, but this is a big thing in algebra on inverse functions. I don't know if you want to make a note of that or not, but this is where this comes into play in algebra. And if you reflect a point over the line y equals x, this is an important line. It seems kind of random, but this is a very big algebraic concept, which means I would most definitely quiz you on it, because you need to know this moving forward. When you reflect over that line, your x values and your y values are going to switch places. Now this one's kind of in space. It's easy to, or it's a little harder to find or to understand. But like this point, if I had it at 0y and you reflect, you can kind of see it here. Okay, it would land on my x-axis. I'd now be at, you can almost call it y0, because the y value, whatever it was, say it was 4, is your x value. You have 0, 4, now you have 4, 0. But it's a true even in space. It doesn't matter where you jump here. It's going to give you the same points. So it's kind of cool, and it's easy to learn once you know it, and you need to know it. So know it. Okay. So the last examples that kind of go with this, we have example 4 says reflect the rectangle with vertices 3, 4, 3, 1, negative 2, 1, and negative 2, 4 across the x-axis. Again, I'm just giving you one example. So understand that I could ask you to flip this over the x-axis, the y-axis, or the line y equals x. And you're going to have to go over that in the homework to kind of get that extra practice on it. This is just one quick example to help you see each one of these. So all I would do is understand the rule first, and I'm going to go s prime, t prime, u prime, and v prime. And if you understand the rule for each one, the rule doesn't change actually, because I'm reflecting every single point over the same x-axis, and you're going to be fine. Again, understand you're reflecting over the x-axis. So you're going to move each point over, oops, I did it the wrong way. It's over the x-axis. You're moving each point over the x-axis, so again, you can see it's the y value that changes, not the x value. So all the x values are going to stay exactly the same. So you have 3, 3, negative 2, and negative 2. Those are not changing. Make sure you don't get that backwards. The y value will change though. It's going to be negative 4, negative 1, negative 1, and negative 4. Again, if they were already negative, they'd become positive. They just switch signs. That's really all you need to know. So again, it shouldn't matter what I'm asking you to reflect over. I mean, it does matter, honestly. You need to make sure you know which axis, in this case it was the x, so you know which rule to apply. Make sure you know those. I'm just telling you now. It's going to be important. Okay. So anyway, that's going to be your reflections. Again, I can give you 2, 3, 4 examples on that, going over each rule. But again, if you know the rules, you can apply them. It's not really that bad once you know them. Okay, so know the rules first, and then you can try it out. Number 20, and then you know the other ones in the homework. Okay. So what we're going to have here, I should be telling you this in class, but if I don't, it shouldn't matter because we can talk about it here. We're going to be giving you some lessons, me and Mrs. Moore, that coincides on lesson quizzes that coincide with the lesson that you did. This is how we're going to tell if you did the notes and understood the notes. So we have a lesson quiz here, and again, you have 1, 1, and 2 on this slide. and 3 through 5 down here, and then we have our assignment. This is going to need to be turned in when you come to class. So the lesson quiz, make sure you finish 1 through 5 and bring it in ready to turn in when you come to class. Okay, so do that now since you just did the lesson, and then bring that in with you when you come in, whether it's tomorrow or the next day, depending on your block schedule and how it works out. Okay, once you finish that, this is what we're going to work on in class. Again, this is our class work. So you don't need to finish this, you need to finish the quiz before you come in. Okay, so that'll be up here. And finally, the last little piece that you need to do, and make sure you scan the right code. We have QR codes for me and Mrs. Moore, and these codes are here for you to rate your understanding. So you'll scan the code. I know I've had some students that had issues with the QR codes. If you do, you can just copy the link and go to it that way. If you have the QR code, just scan it now and fill out the form. You do need to do this for each lesson. It just takes a couple minutes, and it tells me how well you understood the lesson. This is important for us as teachers to be able to kind of gauge where you guys are at before we give you a test and we see where you're at that way. Okay, so anyway, go ahead and just a quick one last reminder. Now that you got your notes, do the lesson quiz 1 through 5, do the QR code, fill out that form, and then when you come into class, we'll go over the assignment in class. If you have any questions, also bring those with you. All right, go ahead and get started, and good luck.